All right, everybody. So for today, sorry I couldn't be here, but today what we're really doing is kind of reviewing a concept, or a few concepts that you looked at when you were in 8th grade. Some of you may be even 7th grade, but doing a review of properties of exponents, all of which you've probably seen, but there are 6 main properties that we're going to be looking at today. We're going to look at some basic ones and then some that are a little more complex, but we'll also be working with these on Thursday as well. So the first property that we're looking at is, for the property of exponents, is the product rule. And what this is saying is that whenever you are multiplying 2 exponential expressions, right, and those expressions have the same base, you keep the base and you add the powers. Now, first off, what is a base? What is an exponent? So let's say that we have an expression like x to an a. Okay, this right here, this is an exponential expression, where the big number underneath, this is what we call the base, okay, and the top number, this is our power, or the exponent. Okay, so when we look at the first one, we take a to the 4th times a to the 5th. We are multiplying these 2 expressions, and they have the same base, okay, they have a base of x. The first one has an exponent of 4, the second one has an exponent of 5. So when we simplify it, we keep the base and we add the exponents. So this simplifies to x to the 9. Okay. Now, the next one, we have 2 expressions that we're multiplying. Okay, we have 3a to the 2nd times 4a to the 3rd. Now, these are exponential expressions, but they have coefficients as well. So 3 and 4 are what we call coefficients. Okay. Now, they're not bases, so we don't keep the base, or we don't keep the coefficients. We don't add the coefficients, but because we're multiplying these, we multiply the coefficients, so 3 and 4 is 12, and then with the exponential expressions, we keep the base and we add the exponents. So this becomes 12a to the 5th. For C, okay, we have 3 expressions, so we do the same concept here, right? We take all of the coefficients and we multiply them, right? So that's 2 times 3 times 3. Now notice that we have 2 variables here, okay? So I'm going to take the base for the x, and I'm going to add all of the exponents on the x, which is 4 plus 4 plus 4. We're going to do the same thing for the y. We're going to keep the y for the base and add all of the exponents for the y. So that's 3 plus 6 plus, now here, notice that there isn't an exponent written. So whenever there's not an exponent written, we assume that it is 1. Right? So add 1. So now we simplify it. So 2 times 3 is 6. 6 times 3 is 18. Exponent for the x, 4 plus 4 is 8, plus 4 is 12. Here for the y, 3 plus 6 is 9, 9 plus 1 is 10. So your answer is 18 x to the 12th, y to the 10th. Okay. That's the first property. Whenever you are multiplying, keep the base, you add the exponents. All right, next one, the quotient rule. Okay, quotient is the result of a division property. Okay, so anytime you're dividing, we use this property. So when dividing exponents with the same base, you keep the base and you subtract the powers. Okay, so for the first one, we have m to the 5th divided by m to the 2nd. So here we have a base of m, so I keep the m. We take the 5, we subtract the 2, and we end up with m to the 3rd. That's it. Okay. Now when we go to B, okay, notice we have coefficients. We also have multiple letters here. So for this, I'm going to go ahead and divide my coefficients. Just like up here with the product rule, we multiply the coefficients. Here we're actually going to divide them. Okay, so 8 divided by 2 is 4. For the B, I have b to the 8th divided by b to the 2nd. So we subtract 8 minus 2. Now notice here for the g's. I have g to the 5th and g to the 6th. There are two ways that we can do this, but what we're actually going to do is, because the bigger exponent is in the denominator, we're going to keep the g in the denominator. And we're going to take 6 minus 5. So we're going to subtract the smaller from the larger, but we're going to keep it wherever the larger exponent is. So when I simplify this, we end up with 4b to the 6th over g to the 1st, and you don't have to write the 1 if it's g to the 1st. Okay? And this is our answer. All right, for C, okay, we have 3 variables. It doesn't change the complexity. All we're going to do is we're just going to subtract the exponents from the terms with a common base. So here, x to the 2nd over x to the 4th. All right, notice that the x to the 4th is the bigger one. So I'm going to keep that in the denominator. So I'm just going to draw a fraction line here. And we're going to say x to the 4 minus 2. That's where my x is going to go. Then I look at the y to the 5th over y to the 7th. Well, once again, I'm dividing, so I'm going to subtract. But because the larger exponent is in the denominator, we're going to subtract and keep them in the denominator. When I go to z to the 8th minus z to the 10th, or sorry, z to the 8th divided by z to the 10th, it's bigger in the denominator again, so I'm going to subtract in the denominator. But now notice, all of them were bigger in the denominator. So we subtracted and we kept all the terms down there. So in that case, we need to leave a 1 up in the numerator, just kind of as a placeholder. So my final simplified answer is 1 over x to the 2nd, y to the 2nd, z to the 2nd. Okay, that's the quotient rule. Whenever you are dividing, you subtract. And keep the variable, keep the base wherever the larger one is. If it's in the numerator, keep it numerator. If it's in the denominator, keep it to the denominator. Okay. All right, next property, the power rule. And this says to raise a power to a power, multiply the exponent. So notice here that we have a base that has an exponent. But then that expression also has an exponent. That's when we say a power is raised to a power. So really what this is saying is anytime you have an exponent, you're saying you're multiplying that number by itself. So what this is saying is we have x to the 2nd times x to the 2nd times x to the 2nd. Now, what we just learned up in the product rule is that if we are multiplying terms and they all have the same base, we add the exponents. Well, 2 plus 2 plus 2 is x to the 6th. So with the power rule, what we can actually do is there's a shortcut that we actually just multiply the exponents. So it's x to 2 times 3, which is x to the 6th. Okay. So for B, x to the 9th to the 3rd, instead of saying a to the 9th, a to the 9th, a to the 9th, we can just say a to the 9 times 3, which is a to the 27. So that's the power rule. Whenever you have a power raised to another power, you multiply the exponents. All right. Now, this one's the power of a product. So it's basically the same thing as the power rule, but what it's saying is it's the power of a product. So a product is when you multiply things together. So if you notice in the parentheses, we are multiplying x to the 3rd and y to the 2nd. This entire expression is being raised to the 4th power. So what that means in this case is each base is going to be raised to that power. So just like we did up in the power rule where we multiplied the exponents, here we're going to multiply the exponents each by 4. So it's x to the 3 times 4 and y to the 2 times 4. So we end up with x to the 12th, y to the 8th. Okay. For B, now notice we have a 2. Okay, 2, x to the 5th, y to the 6th, all raised to the 3rd. Even though this isn't a base, it's a number, we still, when we kind of distribute the exponent here, if we think of this 2 as 2 to the 1st, okay, we still want to multiply the 3 to the 2. So we're going to say 2 to the 3rd, x to the 5th times 3, y to the 6th times 3. We take the 3 to all of those, even if it is just a number. So then when I simplify, we identify what 2 to the third is. Okay, remember that's 2 times 2 times 2, which is 8. X to the 15th, y to the 16th. Okay. That's the power of a product. Now, these are our main properties that we're going to be dealing with. Okay. The next two properties on the next page are kind of what we do to clean some things up. We make them a little bit easier, but then we make them look just a little bit neater. Okay, so for instance, the negative exponent rule, okay, is we take the reciprocal of the expression. Okay, or in other words, we move the expression to the numerator or denominator, and you make the exponent positive. Okay, so for this, if I have x to the negative second, that means we're going to move this expression to the denominator. Well, now we don't really have a denominator to move it to, so we're going to write a fraction bar, move x to the second down here. There's nothing left up in the numerator, so we just leave a 1. X to the negative second is the same as 1 over x to the second. Okay. All right, for b, x to the fourth, y to the negative, or x to the fourth, x to the negative 6. Same thing. I'm going to keep the x to the fourth is positive, so we don't do anything with that. X to the sixth we can move down below. Okay. Now from here, we can still simplify because notice that we're dividing terms that have the same base. So from here, the larger exponent's in the denominator, so I'm going to keep it down here. Say 6 minus 4. We don't have anything left in the numerator, so we leave a 1. And we can say 1 over x squared. Okay. That's your answer. For C, we have 1 over y to the negative fifth. Okay, now notice that the exponent is negative in the denominator. So in this case, we're going to take the expression and move it up to the numerator. We're going to move it up here with the 1. Okay, so it's 1 times y to the fifth in the numerator. Okay, if you want to leave a 1 in the denominator because we took everything out, you can. But essentially, 1 times y to the fifth is still y to the fifth. And y to the fifth divided by 1 is still y to the fifth. So your answer is just y to the fifth. All right. Last example with the negative exponent rule. Okay, so here, there's a couple different ways that we can do this. But if you initially just want to get rid of the negative exponent, for this, what we can do is first, I'm going to divide the coefficients. So 6 divided by 2 is 3. Then, if you want to take that negative exponent and move it up top, we already have an x to the 7th, so when I move the x to the 5th up, we have x to the 5th. We don't have anything left in the denominator, so we don't have to write it. Okay, but from here, we are all three of these expressions we are multiplying. But these two exponential expressions have the same base, so we can add the exponents. So we end up with 3x to the 12th. All right, one more property, and then you guys are going to make a little flip book to help you just kind of remember and as an example to know what the properties are, and then you'll have a little bit of time to practice. Okay, so the last property that we're going to look at is whenever we have a zero exponent. Okay, anytime you have an exponent of 0, okay, the expression is always going to equal 1. So x to the 0, answer is 1. Here, 25,000 x to the 17.5864 y to the second. Okay, complicated, big fancy number or whatever, but notice that all of it is in parentheses. So all of the entire expression is being raised to the 0 power. So that means your answer is just 1. It doesn't matter what number it is, if it is raised to the 0 exponent, it's equal to 1. And the last one now. Just because you see a zero exponent doesn't mean that the answer is always 1. For C, the only thing that is equal to 1 is the expression that is being raised to the 0. So here, if you notice 2 to the x, this is the only part that's actually being raised to the 0 power. So this is the only part that is equal to 1. The negative 2 is still part of our expression. So now what we have is negative 2 times 1, which is negative 2. Okay. All right, guys, so there are your 6 properties. Next, you're going to be making a little booklet just as a reminder. So the booklet that you guys are going to be making is a tool that you can use just kind of throughout the unit anytime you need a reminder of what the exponents are. We have quizzes. You'll be able to use that on your tests, but it's just as a tool to help you to give you some examples. All right, and then you're going to be working on a worksheet that you'll need to turn in by the end of class. All right, you guys have a good day.